In this video tutorial, what we're going to do is we're going to look at three different examples of multiplying fractions. Our first example here is asking us to find 2/5 times 1/3. And so to do this, we're going to look at this one actually two different ways. The first thing we're going to do is we're going to actually explore a algorithm or a rule for multiplying fractions. And usually the way to think of this is if you have A over C times B over D, the way to look at this is to just multiply the numerators together, A times B, over the denominator, C times D. So we just multiply the two numerators together and then multiply the two denominators together. So let's actually do that here in this case. Since we have 2 over 5 times 1 over 3, when I combine my numerators, I'm going to have 2 times 1, and my denominator will now be 5 times 3. And so we can combine those. 2 times 1 is 2, and 5 times 3 is 15, 2/15. And that's already simplified, so we don't need to worry about doing that. Now, another way to think of this is to actually go back to the meaning of multiplication. And a way we can think of this is really this is asking us for 2/5 of 1/3. And this allows us to make a diagram of this. So I want to know what 2/5 of 1/3 is. So the first thing I'm going to do is I'm actually going to draw a rectangle. It's not a very good rectangle, and I'm going to divide it into thirds. So here's my thirds, and this is 1/3 shaded in. So here is my 1/3. So the columns are representing my 1/3. Now I want to know what 2/5 of 1/3 is. So I'm going to divide in the other direction. I'm going to divide this rectangle into fifths. So there's 1, 2, 3, 4, 5. It's not very even, but you get the picture. And I'm going to shade in 2 of those fifths. So here's those 2/5. So going across my rows, I have shaded in 2/5. So what I'm really looking for here in terms of finding my 2/5 of 1/3, I'm looking for this region here where I've shaded in both the thirds and the fifths. And we can actually tally that up. So the first thing I'm going to do is I'm going to actually count how many different pieces I have all together. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or another way of thinking of this is a 3 by 5 array looking at the denominators. So I have 15 individual pieces, and what I have shaded in is 1, 2 of those, or an array made by the numerators, 1 times 2. So it's just another way of sort of visualizing that 2/5 times 1/3, or 2/5 of 1/3 is equal to 2/15. So we have a way that uses a rule, and we have a visual way of showing multiplication of fractions. In the second example here, we're asked to multiply -5 over 24 times 16 over 25. So we're going to make use of our rule in this case, and I'm going to combine -5. So remember that negative sign, I'm just going to kind of think of it as being attached to the numerator, times 16 in the numerator, and my denominator is going to be 24 times 25. Now, one thing I can do here is I can just multiply 5 times 16 and 24 times 25, and actually let's just do that. -5 times 16 is -80, and 24 times 25, well, that's big. 25 times 25 is 625. I think that's 600. And I can then simplify that. I'll get rid of the tens, and I'll divide both the top and bottom by 4. So I get -2 over 15. Oh, that's kind of funny. -2 over 15. That's one way to do this, but multiplying 24 times 25 mentally probably is not so easy for everybody. So let's look at a different way of doing this. And what we're going to do here is we're going to do some simplifying before we multiply. So if you notice, this 5 and the 25 here, actually I'll highlight those, this 5 and this 25 have a common factor, and that factor is 5. So I'm going to actually reduce or simplify both of these by a factor of 5. So that becomes a -1, and this becomes a 5. And likewise, I can actually simplify the 24 and the 16. They have a common factor as well of 4. So I can, actually, yeah, 4. So I can make that a 4 and make this a 6. And actually what I notice is I could simplify those even further by another factor of 2. So 2 and 3. So now what I really have here is I have, I'm going to just simplify this, -1 times 2 over 3 times 5. And when I combine that, -1 times 2 is -2, and 3 times 5 is 15. So same answer, but in this case I simplified before, and in the case over here in pink, I simplified at the end. So, it's definitely a good idea to simplify ahead of time if you can see it, because then it just allows you to work with smaller numbers. The last example here has us multiply 1 1/3 times -2 3/7. Now, I'm going to put these into improper fractions, and believe it or not, you don't actually have to put them into improper fractions, but it tends to be a little bit easier. So I'm going to combine 1 and 1/3, so 3 times 1 is 3, and then plus 1 is 4, so this becomes 4/3, and times -2 3/7. Remember, even though this is negative, we convert it into an improper fraction the exact same way. 7 times 2 is 14, plus 3 is 17. So I get 17 over 7. And so now I'm going to look for, I'm going to put those together, 4 times 17 over 3 times 7. And I'm going to look for any places where I can simplify. And so 4 has there's no common factors with the 4, and there's no common factors with the 17. So now I'm just going to combine those together. 4 times 17, I believe, is 68, and 3 times 7 is 21. So since there was no places to simplify at the beginning, I know this is already in simplest form, but if I want, I could also put this into a mixed number. 21 goes into 68 3 times with 5 left over, so 5/21. Either one of these are acceptable final answers. They're both simplified. Just one's a mixed number and the other is an improper fraction.